Hello, I'm Chad K, and today I will be talking about time travel. The aim of this podcast is to share fascinating facts about various subjects, all accompanied by calming, soothing music in the background. My goal is to help you unwind and enter a peaceful state of mind, or assist you in drifting off to sleep after a long day. So find a cozy spot or lie down, close your eyes if you would like, and immerse yourself in these relaxing facts. Whether it's truly possible to travel back in time remains unknown. If it could happen, it would raise serious issues about cause and effect. For example, the idea of changing past events. Traveling forward in time, however, is a proven concept grounded in Einstein's theories of relativity. Time appears to pass more slowly for objects moving extremely fast or in strong gravitational fields, but the effect is tiny with today's technology, only a few milliseconds. Some mathematical solutions in general relativity suggest time travel might be possible under certain extreme conditions, such as near a spinning black hole or within unusual space-time structures. These solutions allow for what are called closed time-like curves, loops in time that could let an object revisit its past. While interesting, these remain theoretical and rely on features of the universe that don't seem to exist in reality. Going back in time introduces major paradoxes. One famous example is the grandfather paradox, where a time traveler could prevent their own existence by interfering with their ancestry. To solve such problems, some scientists propose that events in time may be self-consistent, meaning the past cannot be changed, or that each trip back in time creates a new, separate timeline, ideas based on interpretations of quantum physics. Relativity does allow for speculative concepts like wormholes, cosmic strings, and warp drives, which might permit time travel. These ideas involve faster-than-light movement or highly warped space-time. But once quantum effects are included, many of these theoretical loopholes appear to close. Stephen Hawking proposed that the laws of nature might forbid time travel entirely to protect the order of events, what he called the chronology protection conjecture. A full answer would require a theory that unifies general relativity and quantum mechanics. Wormholes, if they exist, could connect distant points in space and time. By moving one end at high speed or into a stronger gravitational field, time could pass differently on either side. A person entering the younger end might emerge from the older one, effectively going into the past from an outside perspective. However, such travel is limited to the lifespan of the wormhole itself. To work, wormholes would require exotic matter, a type of material with negative energy, which might be possible due to quantum effects like the Casimir effect, though building one is far beyond current science. Physicist Matt Visser argued that moving wormhole ends in this way would trigger quantum or gravitational effects that might destroy the wormhole or push its ends apart, preventing time travel. He later proposed a complex system of multiple wormholes, called a Roman ring, that could bypass this, though it may reflect flaws in current theories rather than a real possibility. Another theory involves a massive, rapidly spinning object known as a Tipler cylinder. In theory, if it were infinitely long and spun fast enough, it could allow a ship to look back in time. But the required materials and speeds are beyond what we can produce, and finite versions of the cylinder may not actually work. Hawking also showed that without exotic matter, which violates typical energy rules, creating a time machine would be impossible under general relativity. His theorem supports the idea that time machines cannot form in realistic conditions. In relativity, information or signals moving at or below the speed of light always obey the normal flow of time. But if a signal moved faster than light, it could be received before it's sent, suggesting time reversal. This leads to ideas like the tachyonic antitelephone, a hypothetical way to send messages into the past. Still, there is no evidence that such particles or signals exist. Quantum phenomena like entanglement or teleportation might seem to suggest instant communication, but they cannot be used to send usable information faster than light. The no communication theorem confirms that quantum mechanics does not allow backward time travel or faster than light messaging. Some physicists have proposed that time travelers might not change their own past, but instead enter a different universe altogether, one of many possible timelines. This idea, based on the many worlds interpretation, avoids paradoxes by separating actions from their consequences. However, critics argue this approach stretches the limits of quantum theory and may not apply to larger objects like humans. Experiments such as the delayed choice quantum eraser show how quantum measurements can seem to influence earlier events, but they don't violate causality because no information is actually sent back in time. Some argue that if time travel were possible, we would have seen visitors from the future by now. But this is not conclusive. Perhaps time travel is too difficult, too dangerous, or cannot go back further than when the time machine was first created. Stephen Hawking humorously noted that we haven't been overrun by tourists from the future, which might mean that it's not possible after all. There have been real attempts to invite time travelers, like MIT's Time Traveler Convention and Stephen Hawking's Party for Future Guests, but none have shown up. Some speculate that travelers might arrive in a different timeline based on alternate universe theories. In 2009, Hawking did an experiment where he hosted a party for time travelers, but he did not send out the invitations until the next day. Hawking said that he hoped that copies of the invitation might survive for thousands of years, and that someone living in the future would find a copy and go back to the party. No one showed up, and Hawking regarded the event as experimental evidence that time travel is not possible. Time dilation is a proven aspect of relativity and has been observed in particles like muons and in GPS satellite clocks. It shows that someone moving very fast or near a massive object would age more slowly than someone elsewhere, a real, if limited, form of time travel into the future. The twin paradox explains how one twin who travels into space at high speed would return younger than the one who stayed on Earth. In theory, a powerful gravity source, like a compact sphere with Jupiter's mass, could slow time drastically at its center. But creating such an object is far beyond our engineering abilities. With current technology, space travelers can only experience a few milliseconds of time difference from Earth. And that wraps up my talk this week about time travel. If you enjoyed this episode of Relaxing Facts, please consider subscribing or leaving a comment. I hope you have a wonderful day, whether you are unwinding after a busy day or just relaxing with some pleasant listening. Thank you for joining me. I am Chad K, and I'll see you next time.